Okay, so this is the example. You can actually see the spreadsheet on page 300. It's discussed on 336, 337. You can see the spreadsheet on 337. Okay, so the idea is that we are forecasting, again, one ahead forecasting, where we basically forecast using the previous values, and we're doing it for exponential smoothing and different values of alpha. So in fact, the equation we're using is equation 9.6 on page 335. And we're using that to implement exponential smoothing. So the alpha is the smoothing parameter. And basically our forecast is alpha times the actual value at the previous time period plus 1 minus alpha times the forecast. So i.e., we're slowly updating our forecast with the actual value and smoothing it. And different values of alpha give us different values of smoothing. If we chose an alpha of 1, then our forecast would just be actually the previous actual value. If we chose an alpha of 0, our forecast would be the previous forecast. It would be the first forecast because it would never actually update. So we're basically going to select all these different values of alpha. So let's just put the whole sheet on Arial 12 to avoid having to update. And our first one, if you look at the spreadsheet on page 337, we're doing 0.1 to 0.9. So we're going all the way to K. So I'm just going to put in D3 equals this plus 0.1. And then we can just select up to K and control R. And each one is 0.1 plus the previous cell. I'm going to do this like the book does it, and then I'm going to do it my own way because I think there's a more efficient way of doing it. So let's just get our borders right. There we go. Why did I do the top border? Okay, I messed that up completely. Double bottom border. That's much better. Okay, so let's just think what we're doing here. So for an alpha of 0.1, now the first, we don't have any previous values here. So this is almost like, this is what we sometimes call a burn-in period in forecasting. So we just have to put the actual value. We can't forecast in period 1. And that's going to be our initial forecast. So we want alpha times the previous value plus 1 minus alpha times the previous forecast, which is this one. Now, this is going to be 88. This is not going to change. Now, a few things we need to do. Again, we want to kind of dollarize the B. Okay, so we had the dollar on the B. So when you drag across, we're still dealing our actual column as B. We do need to do one more set of dollars, and that's on the C3. We need to put a dollar on the 3, because when we drag down, we still need that 0.1 to be our alpha. So hopefully, this should able to first go across. So we see here that we are still the B for the actual, but we're now E, F, G for both the alpha and the previous prediction. And we should be able to drag down. Oh, wonderful. And you see here, let's just take one in the middle. You can see that we still have the alpha up there, the 0.4, because of the dollar we put on the 3. And we're in column F, but we still have the B. Okay, so that's wonderful here. Let's just go this one. So we're basically alpha times my previous forecast plus sorry, alpha times my previous actual plus 1 minus alpha times my previous forecast. Okay, so that's pretty good. Now let's just do it to the same format that was in the textbook. Format cells, number, 2 decimal places. Okay, so that should be looking exactly the same as the textbook. Let's just bring our double lines across to make it look identical. We'll click there, more borders. Got double lines, and we'll just select them at the bottom and the top. Okay, so the mean absolute deviation. So that's going to be equals, and it's going to be the absolute value of the actual minus the forecast. And again, we can't do it for week 18 because we don't have an actual. We need to actually dollarize on the B's because when we want to drag it across, that's still going to be the actual. And we actually need the average. So we've got of these values, and we need 2 brackets. Perfect. And let me just check that kind of matches. Oh, what we want to do, we want to start off at 5. There we go. We match the book. And that's the idea. This was really just a burn-in setup, so it shouldn't be included in the actual forecast. Okay, and we can Control R, and then we should get the values to the right. So let's just actually copy this, and we're still doing something similar. And this time we want the mean squared error. Now, rather than having the absolute value of the differences, we just multiply them and then we average them up. This is nice in that Excel, you can work with arrays like this, in that we did the subtraction on the array and we did the power of 2, so we still have an array, and then we kind of find the average of the array. And we get 496.07. Just check that actually agrees with my textbook. Control R. And the mean absolute percentage error, that's actually a little bit more tricky. But let's just start off with the mean absolute deviation. And we need to do basically the percentage error is the absolute error over the actual, and then we can multiply it by 100. This time we're actually just going to use the percentage formatting, as that's what the book does. So the absolute value of this all over my B, but we need some extra brackets because it's the difference that's divided by the actual, not the actual forecast. And then we can do to the right. So again, if you're not quite sure what I did here, just kind of look back to those error formulas we had a few pages ago. It's basically the error divided by the actual. So how much of the actual is error, but the absolute value of that. And we just need the averages. So let's just forecast, change these to 2 decimal places to make it consistent. And this we're going to format as a percentage. Right click, format, and percentage. There we go. Now we're going to do one more. Now the idea here is we basically getting all these different values of alpha, and we're trying to find the minimum error. So we'll start off 0.1, 0.2, 0.3, 0.4, 0.5. The error's still going down, 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 down. We get to 0.6, and you see the error's 14.71, then 14.6. It starts going up again. So we'd say here that 0.6 is the lowest error. But let's just start off, and let's just imagine at the beginning we think that the alpha is going to be 0.5. So we can actually drag everything across. We should be able to, for an error of 0.5. You see, this is exactly the same as the 0.5 we have here. But say, for example, now we can use Solver. So go to Data, Solver. And basically what we want to do is we want to minimize our error by changing this cell here, subject to the constraints. Now, this thing here, make unconstrained variables non-negative, it means that our alpha is greater than 0. But we also have to remember our alpha is kind of bounded. It's a weighted sum, so it's between 0 and 1. So we'd actually add, this is going to be less than 1. And we're looking for the minimum, then click Solve. And there we have it. Our best possible alpha is 0.6364. And let's just because I'm so pedantic, let's just make sure we have a bottom border on that. And so this would actually be the optimal solution. I mean, you could also kind of plot this graph for different values of alpha, but this is how, when I've taught this in the past, I've done this in the past, this is actually how we do it. We do it with Microsoft Solver. The book here is just get lots of values of alpha and find, approximately the lowest, but we can get the exact best value of alpha using Solver. So that was just like my little addendum to the textbook.